Hello, you're with Nanoprobes. I'm Rick Powell, and I'm here to introduce FluoroNanogold, which is our combined fluorescent and gold-labeled immunoreagent. You can use FluoroNanogold to check your labeling by fluorescence before you start electron microscopy processing of your sample, and you can also use it for correlative light and electron microscopy. What is FluoroNanogold? Here's an example. It is a combined fluorescent and gold-labeled probe in which a fluorescent tag and our 1.4 nanometer Nanogold gold label are attached to an antibody or a targeted protein for labeling. It's a dual immunoprobe that contains both a gold nanoparticle label and a fluorophore. The 1.4 nanometer Nanogold label is small enough that it gives low fluorescence quenching, lower than larger colloidal gold, so the fluorescence is conserved, and you can actually see both labels. Fluorescent and gold labels are separately attached, which separates them and cuts down on fluorescence quenching and preserves the brightest fluorescence. And all the components are covalently linked for site-specific attachment and stability of the FluoroNanogold immunoconjugate. FluoroNanogold lets you take advantage of the complementary properties of fluorescence and electron microscopy. Fluorescence microscopy works on the cell and tissue scale, and you can see how things are distributed across cells and within tissues. It gives you dynamic, functional information. You can see how things move and how they change in real time. You have a wide variety of labels. You can use super resolution fluorescence for organelle level resolution. Electron microscopy gives you macromolecular or nanometer scale resolution and information on the surrounding reference space, so you see the labeling in context. You have two complementary methods that operate on different scales and give you whole different categories of information. So going back to our FluoroNanogold probe, this is the first example that we made with fluorescein and nanogold. How does that look when it's used for immunolabeling? This is the fluorescence microscopy, and in this case, this is the staining of SC35 pre-mRNA splicing factor in HeLa cells. This is a nuclear antigen, and it has a speckled distribution within the nucleus. And here you can see monoclonal primary antibody and combined fluorescein and nanogold labeled FluoroNanogold secondary. And at the top, this is the fluorescent signal, and at the bottom is a control with the primary antibody emitted, showing how clean the signal and the labeling is. At the electron microscope level, this is what you see. And this is the same system where the SC35 pre-mRNA splicing factor has been labeled with a monoclonal primary followed by the FluoroNanogold secondary. And again, the bottom shows a control where the primary antibody has been emitted, so clean labeling, and the distribution is pretty much what you saw with the fluorescence signal earlier. We've since expanded to include a range of Anafluor FluoroNanogold probes. They're brighter, they're more pH stable, and they fluoresce brightly across a much wider pH range than fluorescein and some of the earlier fluorophores. And here's a couple of examples. We have Anafluor 488, 546, and shown here 594 FluoroNanogold conjugates with FAB prime fragments or streptavidin. Again, the fluorescent label and the gold nanoparticle are separately attached, so fluorescence quenching is minimal, and you preserve bright fluorescent signal and see the nanogold clearly and separately. Here's an example of correlative microscopy. And in this case, this is labeling caveolin in ultra-thin cryosections of human placenta. And in this case, an Anafluor 594 FluoroNanogold tertiary antibody, or tertiary probe in this case, streptavidin. And ultra-thin cryosections labeled with chicken anti-human caveolin primary, biotinylated goat anti-chicken secondary, and FluoroNanogold streptavidin tertiary. And as you can see on the left, is the cellular distribution of caveolin. On the right, focusing close up on some caveolin structures at the fluorescence level, and below that you can see how the caveolin is localized at the macromolecular and ultrastructural level by electron microscopy. And we thank Toshi Takisawa for this image. Here's an example of some of the different techniques that you can use to visualize FluoroNanogold. Conventional fluorescence microscopy in A, and super resolution fluorescence in B, showing the increased resolution. And comparing that with the electron microscopic signal and overlaying the two in D, then looking at higher magnification in the bottom row, and then taking some cross-sections along the lines that you see in E and F, and looking at the X-ray compositional analysis of the structure, showing the presence of gold along those lines, confirming labeling. It doesn't only apply to transmission electron microscopy. You can also do correlative light and SEM, and here's an example of this using an atmospheric SEM, where you're observing from one side a wet sample, the optical microscope observes from above, and the electron microscope observes from below. And so you can look at fluorescence and compare that with the atmospheric SEM signal, and this is what you see. And at the top's the fluorescence of tubulin, labeled with FluoroNanogold, and then at the bottom you can see the Nanogold label after gold enhancement, which is a process that deposits gold, and you can see the distribution on the cellular scale, and you can see the individual microtubules at the bottom. We've recently introduced Anafluor 647 FluoroNanogold, which is a good fluorophore for use with super resolution microscopy, particularly STORM. And this lets you combine the ultrastructural level resolution of electron microscopy with the organelle level resolution of super resolution light microscopy. Also, that's available now in IgG conjugates as well as FAB prime conjugates. FAB prime conjugates are smaller, penetrate more quickly, and access tightly restricted interior antigens, whereas IgG conjugates have two binding sites, so they bind more strongly and can give you stronger labeling of surface antigens where you have stringent washes, and you need to make sure that your FluoroNanogold probe stays on. And here's the Fab prime conjugate, and here's the streptavidin conjugate of Anafluor 647. So to sum up, FluoroNanogold is a dual immunoprobe with both a gold nanoparticle label and a fluorophore. You can use it to check your labeling by fluorescence before you start EM processing, and so you know before you start a long EM processing procedure whether your fluorescence microscopy has worked. It's ideal for correlative light and electron microscopy, and you can use it for other correlative methods as well. It's available now with a range of fluorophores, Anafluor 488, 546, 594, and now Anafluor 647 for STORM super resolution fluorescence, as well as the original fluorescein. So you've got a choice of different colors for labeling multiple targets. And finally, we've now expanded our range of FluoroNanogold conjugates to include IgG, Fab prime, and streptavidin. So you have a choice between the strongest binding, the highest specificity, or the fastest penetration through your specimens. For more information, please go to our website and check our FluoroNanogold catalog, instructions, and technical support information. Thanks for watching our presentation. This is Rick Powell for Nanoprobes, and this has been FluoroNanogold. Any questions, go to our website and please email us at tech@nanoprobes.com. Thanks.